2 more minutes. You remember we created this picture while we are discussing about the cipher blockchaining and electronic code book.
Yes. Yes.
Okay. So this is uh, just a BMP file. Now let me see. Let us open this file in hexadecimal editor. Mm. So this is something. Now, how about mm, just what I want to do is butter 68, 65, 6C, 6C, 6F and 0A. This is corresponding hexadecimal code for hello. This is the message I want to send, and this is just the binary representation of the hexadecimal representation. How about put these things somewhere here? I know where I'm putting it. Say starting from 68, 65, 60, 68, 5, C, what is that? I guess C. 6C, 6C, 6F. 6C, 6C, 6F. So this is, I just changed few of the bit like 40th bit, 50th bit, not 50th bit, but the byte. 40th byte, 50th byte, 60th byte, and 70th byte, 80th. So I can keep on changing only this zeros byte, like mod 10 byte. All the mod 10 byte, I can simply keep on changing. If I say how the picture would change, I have said it. Do you see any visible difference?
There was some error. There was some error, no?
Yes, there are some error, but it should not be. Still there is there. No, I don't. No. Let us take some other example. I think I have ruined this hexadecimal thing. This and new. And then save as BMP. Okay, I just changed it. Now let us open this file. Copy. Now this one I am simply opening. With HXT is not there. 8. Now I am simply starting from some position, maybe A0 position I am starting. And I have to go to insert. For the 48, 45. Eight, 45. Now let us see if we can open it. Still, we can open the file. And is there any visible change? Do you see? This is
Can you maximize the image?
I'm maximizing it. This is the original image, and this is the changed image. This one is copy. Do
Yeah.
you change any change?
Yeah. So it looks same.
It looks same, right? So inside the picture, we can send some message, right? Without distorting the
Yes.
picture. Person who received this message, I just sent the picture. Everybody will think, oh, this is a picture. But this picture is actually carrying some information that when they open it in HXD or any hexadecimal editor, I tell him, okay, A0 from the A0 position, you can just read the message. They just read this message from the A0 position. It's doable, right? And actually, it doesn't
Yes.
much changes anywhere. I can. Now here I'm writing A, B, C, D, F, G, H, I, J, K, L, M. All these messages I have written. Still, I believe it will not change much in the. Oh, it changes a little bit.
Color.
Yeah,
Yeah,
the
it
color.
got changed. Hmm.
So I just need to be careful that which are the bits that doesn't have much effect. Probably I have changed the depth of this field. Some of the color I have just made inverted. So that's why these changes happening. But yes, it is doable that even without making any change in any of the picture, visibly there will be no change. But yes, we can send some message. Even if we send this picture as a message, nobody will understand that this is containing a message, right? So this is not only sending an encrypted message, or it is not only a secret message, but also I'm sending a message that information is also not visible to others. Other people will see, okay, that is a picture, nothing else, or that is a movie file, nothing else. But actually, I'm sending a message. Right, long back, the kings used to send message like this. They used to shave the messenger's head, all the hair is shaved, then they make the message as a tattoo, and then they will let the hair grow. Once the hair is grown, nobody can read the message, not even himself. He himself doesn't know that there is a message or what is written there, but that is written on their scalp, and there it is covered by hair. So even the messenger is caught, nobody will understand that he is a messenger and he is carrying an information. So that is called steganography. Okay. And instead of sending a plain text message, we can also make some encrypted message, and also we can send the keys. We can have a symmetric key, and we can simply send the message. The receiver will get the message, and they can decipher the message, the cipher text. So if, he first need to extract the cipher text from that picture or the movie or the song, and then he will need to decipher that with the key. So this is called steganography. Simple. Now
Yeah,
coming to this. Now OpenSSL, has everybody installed OpenSSL, or at least you have that online shell. Please open, everybody. Please open. Just we'll try few things. A few hands on here. OpenSSL. So all these commands that OpenSSL has, CRL, DSA we know, DSA encryption. The ENC stands for encryption. We can use we can do encryption and decryption with this command. Chain P key is a generate a primary key. So all these different commands are there. So this is a random prime number it will generate. OpenSSL prime. So if I just write OpenSSL prime, this is prime.
Generate.
Sorry.
Generate. There is a generate option there, right? Generate a prime.
Yes. Specify number of bits. Okay, number of bits is bit.
I guess hyphen bit.
Hyphen bits integer.
Yeah.
Hmm.
So we can generate a prime number. This is how we generate a prime number using this. And this is truly randomly. This is a random prime number. There is no pattern. Okay, not truly random. That has a different meaning.
Pseudo-random.
This is usually pseudo random. That I explained in the first day that what is a pseudo random and what is a true random. Okay, because the seeds that computer takes to generate the random number, that has some pattern. So that's why we really cannot call it a true random number. Okay. Now the first command that we are going to execute for RSA, open SSL RSA. That means it will create a encryption key and decryption key, or the private key and the public key. Out. Label CD crypto. Then open SSL. Then RSA. Output will be .pm. So this will generate 1024 bit or 204. So it generated a private key. If it generates the private key, it is very easy for us to understand the to generate the public key also. We know the formula now. Yeah, we know the formula how we can generate it, right?
Yes.
No, that is not here. But anyway, we explained that how it is possible. Okay, this is the lecture note. This is the note that I have shared with you guys. Yep, this is how this is the formula that we used. People are waiting. So this is the formula we use. So if we know what is this P and Q and E, then we can easily find the D, right? That's why. So while storing it, really does not need to know, or both need to store both the encryption key and the decryption key. It simply needs to store any one of them, and that's what it did. It just created the private key. The public key we can anytime generate from this private key, because the rest of the information is with it. Like it is generated using two primes. Fine. Now, let us see that what is how does this private key looks like? Cat private.pm, right? This is the private key. But as you see, this is base 64 encoding. You remember what is base 64 encoding? How we encoded a binary string into string, but a binary string into a text string, ASCII string. You remember that? Yes, no, forgot, never
Yep.
heard. Okay, so this is the private key. Now let us create the public key out of this. How we can create this? So this is the private key which I am going to share it, and I have to create a public key which I will share with everybody, and the private key I will store it for myself. So let us create the public key which I am going to share with everybody in SSL. Okay. Private mean output. Let us give it a number now, a name. Say my public. PM just is the format for storing key, nothing else. And what is the format? Format is PM format. I'm using, and it's a public out. Only the public key it will create. So what it did, it just simply calculated this thing. First time I generated P and Q. When I run the first command, it generated P and Q, and then it generated the phi n, then it generated a E. Now next time, the next second command that I executed, it just executed this line, and everything is stored in a file. Simple enough. Now you see we should have two PM files. Yes, my public key is the PM, and where is my private is my private key, and this is my public key. Cat my public key. It also looks like a like it is also a base 64 encoded. This is bigger. Why? Because it also contains the information about P, about Q, about E, the generator, all these things. Okay. So let us encrypt something with this. Okay. Now this is our public key. How we usually encrypt any in asymmetric key cryptography? We usually encrypt with the public key. The person who has the private key, they only can decrypt. Let us do that. Which file we are going to encrypt? Maybe this untitled.bmp, that the same picture file that we created. Or let us try some this text file. Say, oh, hello. Plain, plain. Now we have plain.txt. We have. Should I just rest of the? I'm creating a folder. Which is not required for us. I'm just taking them back to. Okay, these are the three files that we are interested in. So now we have my public key, private key, and plain text. Now public key we are going to use for encryption purpose, right? Now let us do the RSA utility. First, I need to give the input key. Then this is the public file I have mentioned, and text. Cipher.text. That is the file name I am just giving. You guys are following me, or you guys are trying it also?
Yes.
Yes, yes.
Yeah, please try it in your own system also while I am doing that. Comment RSA something.
RSAUTL. I is not there.
Okay, thank you. Thank you. RSA operation error. Loops. Okay, padding. PKCS padding is not checking. Well, padding fine. It should. Ciphertext is generated. So I have not mentioned the padding because it's very small text, and RSA key is itself 2046 bit. 2048 bit. But my text is smaller than that. Hello world only. So it requires some padding, and the padding the padding I have not mentioned. That's why this error was coming. But it generated the ciphertext. No. It did not. It generated the file, but did not write anything in that. What is it? Let us.
That encrypt command should be given, I think, sir. Encrypt with public key, -encrypt.
Oh yes, you are right. I forgot to give that encrypt. Thank you. Cat cipher. Yeah, this is the hello world looks like. Now let us see if we can decipher the same thing. To do the same thing with decrypt private key. Of course, let's see if I do the no, I don't know. Private.pm. Or word. So I used one key, this public key I have used for encryption. Now I am going to use the private key for decryption. Operation unknown. Oh. Covered plane. We got it perfectly. Okay. Makes sense, right? So this is how we can do the RSA encryption and decryption. Now let us come to other thing. Now we know hash. Now we know how to encrypt and decrypt. Now we will learn something else, which is called digital signature and digital certificate. What does it say? Digital signature is hash and then encrypt the hash with the private key. The problem definition is like this. I am sending a data, but how can I ensure that the data, entire data that is received by you is actually sent by me? Nobody else has tampered that data in between. How can I ensure? We know one thing called MAC, message authentication code, if you remember.
Yes. Yes.
We know this thing, and this one we understood, right? Message, then we can now create the hash, then we can encrypt it with the symmetric key. But now we know something called asymmetric key cryptography. It's now easier. Now I really don't need to communicate the symmetric key out of band. We don't need that. My private key is with me and my public key is with everybody. Now, if I want to make sure that I have signed this message or this message is coming from me, what I will do, I will create the hash and I will simply encrypt that hash with my private key so that anybody in the world, they can decrypt that hash with my public key, because that is my public key is with everybody. They can simply decrypt that and they will create the hash of the message and they will check the hash, whether the hash matches or not. Is it clear?
Yes. Yes.
Digital signature. Anywhere I am signing, that means I am simply creating the hash and then encrypting the hash with my private key so that anybody in the world, they can decrypt it with. I could tell you one thing. I could have encrypt the entire data. That also makes sense, right? If I encrypt the entire data with my private key, then also the entire data could be recovered by everybody else with my public key. And that also makes you sure that I have sent the data, this data.
Integrity, how we will check.
Yes, but that also,
Integrity.
yeah, in this, so here integrity is checking. Why? Because the hash is the
Hash is there.
and I am encrypting the hash. My question is why I'm not encrypting the file itself? Then also the same thing would happen, right? Then also the integrity is already preserved as well as the confidentiality is also preserved. I could have done that, right?
But in that case, in previous case, the confidentiality was not required.
Exactly. So when confidentiality is not required, that time there is no point of unnecessarily doing all these things, because the receiver might need want to check, might not want to check whether this is the integrity is preserved or not. That is up to him. But if I encrypt the entire data, anyway, he will have to decrypt the entire data. Unless he decrypt, he cannot read anything. But here, at least they can read the data. After that, it is an additional responsibility he might want to perform, whether the integrity is preserved or not. But the data is always there. I don't need to do anything just to read the data. That's why we are calling it a, that's why we are adding it as a signature. And signature, if usually when we sign on a paper, our signature is always same, irrespective of where we are signing, right? Here, the digital signature will always be different on the on different data. So it is also dependent on the data. It is not just a say digital signature. In fact, until many years we used to think that probably our signature, photocopy of our signature and preserve it in a digital form, and anywhere in the PDF file, if we can cut, copy and paste, that is the digital signature. In fact, many bank people also say digital, you can put a digital signature there. And when I was surprised, what is it? Like, I don't have a private and public key. How it would work? Then I understood. Okay, the guy wanted to say just put a photo of that photo of my pen and paper signature. So many people all know that call that one as a digital signature. But
Electronic signature.
sorry,
Electronic signature.
I don't know whether that would be called as an electronic signature, or I do not know whether that is at all a signature. That is a file. I can copy as many time as I want, and that doesn't require me. Anybody can just copy that file. If I'm sending that file to somebody else, he can simply copy that signature and as a picture and put it somewhere else. So what is the point of having that signature? Pen and paper, still I can understand that it is believed that only I can make that signature. I can make that whatever picture I am drawing, that probably I can only draw, or the letter of my name, whatever, however I am drawing it. Probably I can do that. But when it is just as a digital picture I am taking, anybody in the world can actually reuse it. So what's the point of having a quote unquote electronic signature or digital signature? There is no point. Just some stupid people, they do not understand what a signature means. They say, okay, just put it as a digital signature, or paste the signature, because just to comply with the regulations. But that doesn't make any kind of any security or anything. That doesn't make any sense. In fact, anybody can copy that signature. So it's usually the stupid people say, but I shouldn't say stupid people, because probably they have some compliance to follow. But
No, no. E-signature is very popular. Means legal in legal terms, there is a validity, and many startups are running on that. Stupid people are running.
I can copy that thing. I can create as many as copy as I want. So
It
what's
is
the
not secured. E-signature is not secured.
No, it is not at all. It is. I should not call it as a signature. Like many bank people ask for the original Aadhaar card. So I couldn't make them understand there is nothing called the original Aadhaar card. Aadhaar is a number. It is not at all a card. So it's a number. If you know how to use that number, how to get authentication from that number, if you have access to that particular server, then you can authenticate whether I am who I am claiming. But if you do not have that, there is nothing called a original Aadhaar card. Our Aadhaar card is just a number. It is not even a card. It is not an identity card. That's why Aadhaar card usually nowadays probably Aadhaar card has have like they have issued some this a plastic card and all, which has the national or national
Yeah.
emblem somewhere is there. But previous Aadhaar card that used to come by post, that did not have any national emblem on that, or any kind of that sticker, that 3D sticker that comes down, that doesn't come on Aadhaar card, because Aadhaar is not a card, it is a number. So most of the cases, the people never had understood that Aadhaar is a different thing. This is a completely different thing. It is not the same thing like a PAN card. PAN is also not a card. It is a PAN is a number. So people do not understand that is something else. So we are still running a business like 100 year, like we used to do that 100 years back, because that time there is no centralized server to authenticate anything. But now we have, but we could not understand that. And digital signature or like e-signature, what you were telling is one of such stupid examples that we are still following without knowing why we are doing that.
Yeah, yeah. It is widely means in progress, and also the OTP based signatures are also there. Aadhaar
Okay,
based OTP.
it makes sense. That means that SIM card that I have that is registered in my name,
Hmm.
that yeah, or the SIM card that is registered with my Aadhaar, I can give that OTP. That means it is me. That
Yeah.
is that
Yes.
completely makes sense, and that is how it
Huh.
should.
Yeah, both versions are there. One is at the bottom of the pyramid, OTP is at the middle, cryptography digital is at the top.
Exactly. So this is how now everybody of us can digitally sign any data. For that, what we need to have a public key and private key. How we can generate a public key and private key? Simple. You just install a OpenSSL and you can do that, right?
But we need to register ourselves first.
Yeah.
Exactly. Now the point is we can create any private key and public key, and we can tell the world, hey, this is my public key. But that really does not make sense, because anybody can claim any public key. Like anybody can claim anybody can personify as the Maity and share separate public key to anybody. How I can prove that? Okay, that guy is impersonifying me. He's not the right Maity. How I can prove that? So there is no way to do that. But so far it works well if I know. Now this solves a problem. This asymmetric key cryptography solves a lot of problem. At
Yeah.
least not have to share the symmetric key. There is not that overhead. Even for DPLman, we had a problem that we had to take care of n factorial number of keys. So many keys we have to keep track. Now those problems are solved. Now the new problem has come, that how I can ensure that this public key and private key pair belongs to the right person,
Yeah.
or the person who is claiming the ownership of the public and private key is the legitimate authority. How can we do that? But technologically, we are fine. We do not have any problem. Give me any data, I can simply sign it and I can send it to anybody. I can using OpenSSL, I can just create as many as private public key pair I want, and I can keep on signing any document I can send that. But in practice, it is difficult. It is not a good solution. It cannot happen. It is not a scalable thing. So how can we solve the problem? Give me some.
Yeah. Yeah. Digital certificate. For that reason, digital
What,
certificate came.
what is that? What is that? Okay. Before coming to digital certificate, tell me how we can register this public and private key here. How we can tell everybody this public key belongs to this person and who is the legitimate authority. How we can do that? Technologically, mathematically, as a engineer, any idea that is coming in our mind, how we can do that?
Means I didn't get your question actually.
Okay. I created a public key.
Some
Right?
voice got lost in between.
Okay. Mm. So this
We need to ascertain that public key and private key pair is of the same person.
is no. That is easy. Whoever knows the private key, he can always claim that, okay, just send me something encrypted with my public key. If I can read that, then I own the private key. That's not a problem.
Okay.
But the problem is, this is the public key. Now I shared this public key and I shared to the entire world. I mailed everybody, whoever I know, I just let them know, hey, this is my public key, this is my public key, this is my public.
Hmm.
I can announce it. The two questions. First of all, how can I announce that everybody in the world will know? First question. And secondly, even if I do not want to communicate with everybody, at least there are few persons, how I can share my public key, how I can, because say part you can also share another public key and you can claim that this is the public key of Soumya Maity. Or I can share this public key and I can say this is the public key of Dr. Shinu, right?
Yeah.
How or how this thing will work? Any engineering solution, technical solution, social solution, anything? This is the problem. Now, how can we solve?
So, I mean, this certificate, digital certificate and certification authority is not the answer. Then I need to think then.
The answer is that is the answer. But what I wanted to listen is that it's some trusted authority, not certificate authority, but any trusted authority. Just per se, if in the class I am claiming this is my public key, probably all of you will trust. Or if Dr. Shinu comes and shares all the public key of all the instructor, probably you will believe because that came from a trusted authority. The meeting link, when it is sent by Pranav, you guys trusted. Okay, this came from Pranav because he is the officially appointed TA, and I trust this guy. So you use that same link, but instead of Pranav, if somebody else like who you do not know, unknown number, just send you a WhatsApp message. Yeah, for today's class, click on this link. Will you do that? Probably no, because you do not know the person who has sent you. So to implement that system, to implement how we can share the public keys, we need to trust on trusted authorities. Say if you know me, if I tell you this is my public key, or if I tell you that this is Dr. Shinu's private public key, probably you will trust because you know me personally. You know me for the past few weeks, so you will trust me. Or you might think that, okay, this guy is appointed by Dr. Shinobi for teaching us. So whatever he is saying, it is we can trust. So this now comes a chain of trust. First, you trust the authority, Deva authority. Then you trust Dr. Shinu. Then you trust whoever Shinu has introduced to you. Similarly, you trust Pranav because Pranav has been introduced by Dr. Shinu, and Shinu is the official person for Reva University. So that's how the chain of trust is created. You are getting my point. It is not only a certifying authority, but anywhere we are getting any public information, we always think about that trust factor. Otherwise, it will be like any of those WhatsApp forwarded message. All those information, but we really do not know which information are true, which are false. But if I share you something related to cryptography in the group, probably will trust without even doing a fact check. You might trust. Okay, this has come from Dr. Maity. That means we can trust that because we trust this guy. Probably you will think in that line. But if all of a sudden in your school group somebody says that RSA cryptography is broken, do not use bank website or whatever. Do not use online banking. It is all open. No cryptography is working. Something. We get all these messages, right? Every now and then. So in those cases, the trust factor matters, and that is the major thing that we need to implement this entire asymmetric key cryptography system. And we call that system PKI, or Public Key Infrastructure System, which is built on not on trust. which is not built on it doesn't require any other technological knowledge. Believe me, whatever technology, whatever mathematics, whatever theories, whatever engineering aspect was there, we have already covered that till this RSA cryptography or ECC cryptography. After that, what we are discussing now, this is more of a social implementation of the thing. Here we do not need any. Here we have no engineering aspect. So digital signature, what we saw here, this is the engineering thing, of course. But how we are implementing this public and private key pair, how we are sharing the public key, for that we do not need any engineering gain. What we need is understanding how the society works. It is the same thing we are going to implement in a system. And that system, we are going to call it public key infrastructure. Make sense? Clear?
Yes, sir.
One more. Similarly, one more thing is code signing. My company Dell is creating a lot of softwares, and it is there in the website. But now, how people will understand that the software is really created by Dell or any company, Dell, IBM, Microsoft, whatever. How we can know that the package that is coming, package means a software bundle that is coming to me, whether this is actually coming from the developer, or it is not some malicious person. How we can make sure that? One way we have seen that MD5 hash or SHA-215 SHA-256 hash, all these things that we share, we have seen. That's how we can check the integrity of a file. Fine, that is one way. Another better way is to digitally sign the entire package that you are sending. All the entire source code that the developer has written, simply sign that entire source code and send that. So if somebody changes any of this code, they will get caught because the signature will not match. So that is another better approach, code signing. So everywhere, anywhere you are working, anywhere, any company is sending any software package, any application package, any code, piece of code, it should be signed. We know what this signature means. And the company has their public and private key pair, and that is not created using OpenSSL, or that might be created using OpenSSL, that's fine. But that's not randomly created and randomly generated. That is not randomly, but ad hoc generated thing. That is generated, there is a key ceremony happens. So whenever a company generates the new pair of public and private key, they call it a key ceremony. And the key ceremony means in that ceremony, even though they have nothing to do or nothing to speak, still a director, a VP rank leader, and should be present there, and the person who are there in that code signing code ceremony, key the ceremony, they should sign on a non-disclosure agreement that what has been used for generating this code, and all these things there should be a NDA. All these things needs to be done for the key ceremony, and that's how one key is generated and the public key is announced. How it is announced, that I'm coming right now. This is called certifying authority. So now we know everything works on trust. I have to find somebody who I trust. Now, how we can implement the system? Now, just imagine a world where there is no World Wide Web, there is no central authority, nothing like that. The entire world is flat and anybody can connect with anybody. Once upon a time, world was like that. How the concept of certifying authority would work? So, all these big companies like Microsoft, Google. That time I don't think Google was there when the certifying authority concept of certifying authority came. But that time there are big companies like Microsoft, IBM. IBM was a very big player that time. And then Apple, all these companies, and WWW consortium, that Tim Berners-Lee's consortium, all of them were there, and they thought, okay, Let us create an authority. That authority will have all the responsibility for storing the public key of the person. How that authority will work, that they will decide, but this is something we are going to trust. If anything goes wrong, this authority is going to be responsible. So they created an authority, which is kind of a consortium and a root level authority. Now, after that, there are thousands of different root level certifying authority. Now, Google has their own, Amazon has their own, IBM has their own, even every government has their own. In India, we have mca.gov.in. This is the website, and you can actually, these are the certifying authority that government of India, they recognize these are the companies who has authority to act as a certifying authority. NIC, almost all the government websites are are sign the key, the public key of all the government website in India are either maintained by NIC or NIC is acting as a certifying authority for them. IDRBT, all these things. So there are NSDL, all of us know NSDL, CDAC. So these are the government designated certifying authority in India. Different country has different other certifying authority. And if you go here, this is the root CA of India. This is a gov.in website, cca.gov. So all these certifying authority, yes, these are designated by in the government of India. But on the top of that, in India or Indian government, this is the root level certifying authority, which is a department inside government of India. It is Ministry of Electronic and Information Technology, NEIT. And the controller of certifying authorities is a designated office. There is a designated department. That department actually creates all these root certificates. So in India, if you just trust Indian government, what you have to do, you have to download this certificate. This is the certificate CCA India 2020. You just download this certificate and install it in your browser. You open it. This is the certificate. CCA India 2020 issued by, this is the root level certifying authority for India. This is a fair assumption that we are trusting the Indian government, and this is coming from their Ministry of Electronics and IT. And this is the defined certificate value. So now browser is my client, or every browser that I am using through so browser is the gateway or my client, right? Browser needs to know which are the certificates it is going to trust and which are the certificate it is not going to trust. So root levels here in India, if we trust Indian government, we can install that certificate as a root level certificate. Or we might use something else. If we trust Google, or if it is a Chrome, then of course pre-installed certificate is Google root authority. And this is how we can see the certificates. Do we have Chrome installed? I don't think I don't have Chrome installed. So now this is the trust. This is how we create the chain of trust. This is how the trust works. My browser trusts some people or some authority. And if that authority says, okay, this is a valid certificate, it is a valid certificate, or this is a valid public key, then it is a valid public key. Make sense?
Yeah.
If you go here, you can see that what are the installed certificates. So, privacy and security. I think now it is in the OS level also the certificates are installed. Yes, manage certificate. If you come here, you'll see these are the trusted root certificate. So many different root certificates are already installed here. It's too many actually. We should not have so many, but anyway, it is already installed. CCA India is there, certifying authority, etc. So this Entrust is a famous certifying authority. Microsoft is there. GoDaddy Global, saying I don't know. So many different root certifying authorities installed in this browser. So any of these guys, any of these people, if we take, my browser will trust these guys. If it is coming from anybody other than these guys, my browser will not trust them unless I trust them personally and I add their certificate here. My browser will not trust. This is the intermediate certifying authority. This is the root. So intermediate is, it might be my organization, it might be myself. So this is myself. XPS MIT is myself. So these are my own public key, private key pair that I have made it as a trusted one. Now we are talking about certificates, and we talked about what is a certifying authority and all. But what is a certificate? Now let us define what is a certificate. The certificate is nothing but a document that carries some information about a person or a organization or a authority or a system. It carries certain information of that and also carries the public key of that person or system or authority or whatever, or that entity rather. Any legal entity might have a certificate. So it contains that public key along with some other certain parameters. It is just written in a plain text on a file and then digitally signed by somebody who I trust or my browser trust. Simple. We know what is digitally signed means. Who can sign it? So my browser only needs to understand, know few of the public key who my browser trust or who I trust. Using those public key, we can verify any certificate. If that certificate is with me, like if somebody sends me a certificate and the certifying authority's public key is with me, we can verify the certificate. Okay. And what are the
Oh,
parameters that plain text content that we just saw here? These are the parameters. They open. If I go to details, these are the parameters. Version, serial number, every certificate has a serial number. What signature algorithm has been used? What is the hash algorithm used? Who is the issuer? Who is how, like what is the window for which this certificate is valid from and valid to? Subject of that certificate, public key. This is the most important information. These are the public key, different other parameters. This is the key identifier. For every key, there is identifier for the certifying authority keeps a track on that. These are the basic constants, some data. This is when this certificate can be used. And this is the thumbprint, or this is another hash value or another digest of the entire certificate. If we want to see it in the Open SSL, that also we can do. Okay, for that, before doing that, let us quickly create a digest for a file. Let us quickly sign. So we have seen how the encryption and decryption work, but how this digital signature works. Open SSL, GST, then let's see, use 256, and then sign. My private key is anything else? The file name I have not is. So this is the file that it is creating a digest, or this is signing this file. This is the output, the signature, and this is the private key. These are the three information I need to sign any file. It's done. So my signature. So this is the signature. Now, if how I can verify the signature? Open SSL DST short hash used, verify, then
Public key.
sorry,
Public key.
yes, public is required, correct, for my public key.
My public.
And then what? Um, then the signature, right? Signature is signature, that this is the file name and my original file. Verified, okay, it just checks it. So I made the signature with my private key, but there, and this finds the signature, it's very verified. Similarly, if we just create a certificate, we can just take any certificate, and we can try to figure out that what is there in the certificate. For that, let me open the same certificate. Download. Open terminal here. What is the name of that? CCA India, right? Open. And then X509 is the format. X509 minus in India 20. Sir. And this should look. This is just the certificate. And what are the parameters? How can I see? Certificate. So this is the different data. So this is the data, simple plain text data. The same thing, version, serial number, signature algorithm, all these things are written. When we are using the RSA public key 4096 bit, this is the modulus. You remember what is modulus? This is the exponent. If you have remembered, these are the modulus. This is the modulus. This n. This is the exponent. You can. This is the modulus. This is the exponent. And the other different parameters for the key, which I need to understand about the key. These are the information about the key, right? And this is signature algorithm. All these things, and yeah. So this is how this is what is written in a certificate. Makes sense?
Yeah.
This is what a digital certificate is. Digital certificate is often called X509 because that is a format, that is a standard format that is used for digital certificate. Otherwise, what will happen? Different browser, if different browser uses a different can read different format of the certificate, then it's very difficult to implement. Or different certifying authority issues certificate in different format, then it is a problem. That's why all of them agreed. Let us use one single format, which is called X50 format, X509. And now it comes with the PKI. Now we know what is a certificate, how the certificate works. We know what is well, like this is for storing or sharing the public key for any entity. Now PKI has five component. One is certifying authority, obviously. Then organization registration authority. I can create my own certificate, that is fine, but that doesn't mean my authority or my entity is a authorized registered authority or a authorized entity. So certificate and ORA are different. If I want to if I want to get a certificate, fine. If I am an individual, just I need to show them the some that any of the identity card or any of the identity that I can show. Now we can create any public and private key pair for us. We can get it a digital key, and all we need to give is our Aadhaar card or any other. Even if you do not have Aadhaar card, any PAN card or anything, if you just go to certain authorities and if we just register ourselves with them, they will create the certificate for us. Now, actually, many of the cases, these two are same authority. Same authority are running two business. Certifying authority is a different business. ORA is a different business. Now the person who is checking my identity and all, he is a different. He's doing a different business. For that, he's charging me. And after that, once I'm like he authenticates me or he finds that I am the legitimate person who I am claiming to be, then he sends that request to the certifying authority, and certifying authority generates a certificate. For that, it also takes some money. Even though most of the cases, these two are like the same companies running to both the businesses. Third is the certificate holder. That is, it might be me, it might be Reva University, it might be Dell, it might be IBM, anything. And the clients or validators, that is our browsers. And the certificate revocation list, that is very important. I'm coming to that. But these four are the basic minimal necessity, and we understand all these things, right? These are the four, like five components. CRL, I am coming to that, but these four, do we understand? Clients is a very important thing. So when we are installing a browser, we should be really careful that where I am downloading the browser, whether this is the right browser, whether this is a well-known and trusted browser, all these things. Chrome, yes, we are using, but there are many browser we are using, many of us are using on our Android phone, which really do not have much trust on that. So we really do not know which are the certifying authority they have registered in their browser, what the browser is trusting or what it is not. So that's why browser is a very important factor. Certificate holders, yes. If I am accessing Google's website, that in that case, I am the client or my browser is the client. Google is the certificate holder because my browser is verifying the authenticity, the certificate shared by Google. And how Google obtained the certificate? there is a ORA and CA. CA issues the certificate and ORA registers the authority, whether it checks if it is an organization, it actually asks for the tax receipt, it asks for the registration certificate, it asks for a lot of legal documents, then only it sends that request to the certifying authority. So that is, if tomorrow I want to have a certificate in my name, what I have to do, I have to go any of these guys and I have to tell them I need that. They will ask for some e-Mathura is a very common one. If you guys if you guys ever purchased a piece of land, probably this is required. You have to digitally sign that those documents, and for that you have to e-Mathura is a very famous, so not Mathura, e-Mudra. So it's a buy certificate. In fact, in that case, you have to obtain a certificate. If it is individual, just take it from here. It starts from 1299, and I can buy my own certificate in Mudra. So it asks for lot of documents. If I share that, it is done. They will send this thing to I think they are registered authority. Yes, they can do. There are a lot of other companies who do not issue certificate, but they takes all these data and validates me and then sends a request to eMudra. eMudra would create the certificate for me. Here from this website only I can create all these things. If it is organization, it is probably much more. That's how we can now enable the Aadhaar-based TSC issuance. We can get the digital certificate from our. Just all I need to do is paying this 1299 rupees and share my Aadhaar number. That's all. I will get my certificate immediately. And with that certificate, I can create my website. Okay.
Yeah.
Okay. What is certificate revocation list? Now, one certificate is issued. After that, before expiry of the certificate, somebody wants to revoke the certificate. Say I have my public key and private key, and after some point of time, I said, hey, my public key is compromised. Somebody else has already copied, or they have already my private key is already leaked. Now, whatever certificate, now I need to generate a new pair of public and private key. And I have to go back to this certifying authority and would need to tell them, if whatever certificate you have issued, you have to revoke those certificate. And this is the new certificate, and you have to give me a new certificate, issue a new certificate, because my public key is changed. My previous private key is compromised. That means that public key is of no use. Now I have to create a new public key and private key pair. And for that, I need a new certificate. What can we expect this CA to say? It says, come on, this is a distributed system. I have already issued the certificate. This is a digital copy. Now all the browsers in the world, they know that certificate. Now how I can revoke it? It's not a centralized thing. It is a distributed thing. Now anybody who is having your private key, he can run any other system and use the same certificate that I have issued. And that is not expired. How I can tell everybody that, hey, that is not a valid certificate, that is not a valid certificate. In that case, what I have to do, I have to tell each and everybody in the world, again, I have to communicate and tell them, hey, this certificate that I issued, that is not there, that is revoked. That is the only way, because it is a distributed system. Got it?
Yes.
Yeah.
So this is the challenge. So for solving this challenge, it is a very clumsy problem. And this clumsy, and the solution is also very clumsy. Every month or every fortnightly, every certifying authority issues a list, a very long list, and it's that list says, hey, these are the certificate that we have issued and these are revoked. This is the CRL list, and it is there in the website. The browser, after validating the certificate, it also sends a request to that certifying authority and check that CRL list. It downloads the CRL list and also checks whether this certificate ID or certificate serial number is there in that CRL. If it is there, then it says no, the certificate is already revoked. So in that case, it will not show you this green lock. It will show you something like it's a revoked certificate. Certificate is not valid. Here it shows the certificate is valid, right? But if it is there in the CRL list, it will not. So where it will get the CRL list, you find it here. CRL distribution point. This is the website. This is the place. This is the CRL my browser is using now. If I go to this website, sorry. What's that? Yep. This is not found, right? CRL. Now it is downloaded. This is the CRL list. Every time, every fortnightly, when my browser updates, it actually updates the CRL for all these certifying authorities, and it keeps a long list of that. So this is the revocation list. See, all these certificates are revoked. Serial number and when the revocation has been done. So anytime it gets any other certificate that has this serial number, it's gone. So this is a very clumsy process, I know, but this is how it works. Make sense? And now let's go to okay. If there is one more thing. Instead of CRL, there is something called OCSP. OCSP is nothing but instead of downloading the CRL, it actually there is another server. It just sends the data to sends the serial number to that server, and that server sends it back whether that certificate issued with that serial number is valid or not. So instead of doing it itself, it sends that to a different authority, so that I am bringing another trusted authority in between my browser and the website, or my browser and the server. I am just bringing another trusted third party. This is how the PKI works. So we now we know what is root CA. Okay, there is something called chain of certificate. So root CA gives a certificate for another certifying authority, intermediate certifying authority. There might be multiple intermediates certifying authority. Root CA says, okay, I am the root CA and I am designating this guy as another intermediate certifying authority. And that intermediate certifying authority again can designate somebody else to act as another intermediate certifying authority. So in this way, it creates a chain of trust. What is that? Let us open any of the website. It will see how the chain of trust works. Certificate path. DigiCert is the root certifying authority. DigiCert had created an intermediate certifying authority, which is DigiCert, TLS, Hy-V, DCC, whatever. This is another certifying authority. This certifying authority has certified wikipedia.org. Now, wikipedia.org has a certificate. That certificate is signed by a public key of this certificate, this certifying authority, CA. But my browser does not know this CA. So this CA again will produce another certificate that is signed by DigiCert, and this DigiCert certificate is there in my browser. Now my browser says, okay, this one is certified by this, who I do not know, but this guy is certified by this guy, who I know. In that case, I validate the entire path. Here is 3. There might be some like 4, 5, 6 level of certifying such authorities might be there. There is something called certificate lifecycle. For every certificate, we have to register. We have to create the certificate. Then we need to distribute the certificate. Then validation of certificate, key recovery. If key recovery means how we are safekeeping the key, how we can recover the key. Usually Usually the root certifying authority's key is there with some escrow. And then the intermediate certifying authority's key is saved with the above level certifying authority. So in this level, the key recovery happens. If the key is lost, how we can recover that? The certificate could expire someday, and there will be a revocation. So these are different life cycle of the. This is the life cycle of a certificate. So certificate life cycle start with registration and ends at either in expiration or revocation. There are two end state for a certificate. Either it is expired or it is revoked. Now different crypto attack that might happen. So we now we understand what is PKI. We understood what is uh, digital certificate. We understood what is digital signature, and we also understood what are the mathematical or the technological basic on which all this system is built. That is cryptography, and how we can attack the cryptography. How we can hack the cryptography? The answer is using mathematics. So, but not always mathematics. There are some engineering way to attack on the cryptography. How brute force? Just the way the rainbow table attack has made. So that is a brute force. I'm just creating hash for all possible strings in the world. That is a brute force. Man in the middle attack. Yes, it is. It is. Even though we are sending the data, we are encrypting everything. But if the key is compromised, somebody can come and make a MITM attack, man in the middle attack. Cipher text only. That means I know the cipher text, but if without even knowing the key, can I get the plain text? Yes, there are possibilities. I know the plain text, I know the cipher text. Can I find the key? That is a mathematical problem. This is a mathematical problem. These three are also three mathematical problems. I have chosen a plain text. Without knowing the key, can I create the cipher text? Can I guess what the cipher text might look like? Or a chosen cipher text, can I guess what is the, can I create a formula by which I can find out that the plain text probably was like this? Or if I know the key, like if I have part of the key, can I guess that how exactly the entire thing works? So all these things, these are mathematical aspect. These are the sorry. These are mathematical way to attack a cryptographic system. These two are engineering, and this is also another engineering one. So this is a very nice thing. How some smart people thought, okay, I do not care about I do not care about mathematics. I do not know much mathematics, but how about when the encryption and decryption happening in the system, I am trying to figure out some other parameters like, okay, how much heat distribution, heat my computer is generating while it is doing that encryption and decryption operation. Now somebody says, okay, whenever from the plain text and the cipher text, there is 0 to 1 conversion is happening, it is creating more heat. When 0 to 0, there is no bit is changing. That means uh, at that very point of time, the heat generation is more less. So this kind of thing, how much noise my computer is producing when doing all these things, how much electricity or how much power it is taking when it is doing the encryption, how much CPU cycle it is taking when it is doing the encryption. So I can people have found out that when it is there is a transition from 0 to 1, that is a certain level of certain level of CPU cycle it is taking. When it is 1 to 0, then it is different. When 0 to 0, then it is different. When 1 to 1, then it is different. Okay, I found that 4 different pattern for when 0 to 1 conversion is happening, 1 to 0 conversion is happening, and 0 to 0, 1 to 1. I know that. Now I don't need anything. I simply take a plain text. When it was doing that decryption, I don't need to anything. I am just checking that when this CPU cycle, how much CPU cycle it is taking, and I can create a pattern of that. I can create a pattern of the key, I can create the pattern of the cipher text, and during that I can also do the decryption because I know when the bits are getting changed. Okay, so this is a another smarter way to attack on the cryptography. And cryptanalysis, we know how we usually do the cryptanalysis. We have seen the frequency analysis, which is a statistical analysis. Analytic is more mathematical one. There are differential, linear, and differential linear. I'm not going into detail of that, but these five names just keep in your mind in case you need. You can Google it anytime if you are interested. But these are more of a mathematical one. The statistical cryptanalysis we have seen, which is called the frequency analysis. I have shown that how it works, and these are little bit different. Will you can just figure it out. Okay. And much like now cryptography is not only just communication, but it is much more than that. Public key, PKI, public key infrastructure is there, key exchange is there, signature, the zero knowledge proof we are using many cases, multi-party communications are happening. So it is just not a communication between Alice and Bob. Now it is much more than that. There is something called homomorphic encryption. That means when we are doing the encryption, that time we know the plain text and the cipher text. Is it possible to create the cipher text from another cipher text without knowing the plain text? Okay, just explaining the homomorphic equation once. Okay, homomorphic encryption says so. There is a message, plain text message. This is still not working. The team viewer is also not working. Since okay, dot of select, optimize speed. Hmm. I think this is worse. Whoever has suggested team viewer, it is I guess this is worse than that. No, it's not working. Okay. Team viewer. Okay. Aim is the plain text. If we apply encryption function on aim, it gives me C. Right? This is what we know. Now there are two functions, say aim1 and aim2. There are two, not function, there are two numbers, aim1 and aim2. In cloud or wherever, mostly for the cloud, what we do? We usually do operations on the cloud, be it a lambda function or whatever. Like all the computation is done in the cloud. So the one of the major problem is that when this M1 is stored in the file in the cloud, it is stored as a encrypted format. So maybe C1. When M2 is stored in the cloud, it is stored as C2. When this M1 is sent over the communication channel, it is sent as C1. When M2 is sent over communication channel, it is sent as C2. So while storing and while in the channel or communication channel, we are always using the encrypted format of the data. Now, when we are making any operation on this data, say I just want to figure out what is the value of M1 plus M2. So I want to run a program in cloud or anywhere in any untrusted computer where I want to add these two numbers. What I have to do, I know the ciphertext, I know the C1 and C2. From C1, I have to get M1. From C2, I have to get M2, and then I have to add. Then we have to create M3, and then again I have to get it back as like set it back as C3. Right? This is how it usually works. Now, homomorphic encryption says if there is any way, if there is any other encryption function apart from what we know, so that if we can just simply we don't need to decrypt it. We are not going to decrypt it decrypt here. Simply we will make C1 plus C2 equals to something C3. So instead of decrypting C1 to M1, C2 to M2, can we directly find somehow from the C1 and C2? Can we directly find what would be the value of C3? If we can do that, then during the operation, during the computation also, the computer or the cloud provider or the untrusted computer, whatever, that will not understand what is the data that I am working on. Got it? This is called homomorphic encryption. So this is all about our cryptography. Anything that you want me to touch on or anything else? So this is pretty much I have covered that what is the basic things about cryptography, how those using those basic things we can create PKI and how it is implemented. But there are a lot of other things yeah, like those are not directly related to cryptography or directly that is not the basic or fundamentals of cryptography, but that is different use cases of cryptography. But there are a lot of such things. So if you now, I guess, since you know what is the basic or the fundamentals of cryptography, it is easier for you to understand any new topic comes in cryptography. Probably it is very easy for you to understand what are they. And if you want me to touch any of them, then we can do that. Guys, sleeping?
No, sir.
Yes, sir. Sleeping?
Yeah.
No.
No, all good.
No, I just asked sleeping. Then you said Parth said yes, and who else said yes? Okay. Okay, so now we do not have, we only have 45 minutes left. So let's take a 5 minutes break and then are you good, right? Or it is too much. Do you need some time to settle down your brain?
What is left to cover for the day?
I'm thinking to cover quantum cryptography and also blockchain. Maybe I'm just taking 30. I thought that 30 minutes for blockchain and 30 minutes for quantum. But that we are already running short of time. We have to do it.
Assignment is also there.
That should we do now or after 5 o'clock?
That will take half an hour, 1 hour.
All right. So that I thought that after the class. After the class means
Yeah.
after the class means after 5 o'clock.
After 5 we'll take.
Okay.
So we'll take 10 minutes break then. 5 minutes break.
5 minutes. Yeah. Let us take it. Let's 4:15 we are coming there. Okay.
Okay.
Good to go. Good to go.
I'm here, sir.
Is everyone back? We could wait for a minute or so, sir. I think they're coming.
Okay,
Yeah.
sure. Everybody back. Think well servicing.
Yep.
Okay, let us start.
Sure.
Okay, blockchain. What you guys under when we somebody says blockchain, what is the first thing that comes in your mind?
Cryptocurrency.
Cryptocurrency. Okay. And anything else? Okay. In the recent past, how many times you have heard this term blockchain, and how many of you have really know that what is blockchain, what is the technology behind it? So, is there anybody who knows that what is the technology behind blockchain and how it works, or at least have some fair idea? Okay, before going detail of the blockchain, I'm just this is something like for the most 10 top strategic technology of 2021, blockchain is one of them.
Yes, I know some of the things on blockchain, not much.
Oh. And the promises of blockchains are there almost for 1 decade. We are listening about blockchain. At least I knew about blockchain 1 decade ago, like 2011 is first time I come to know about blockchain and Bitcoin. And yeah, for and since then only whatever I'm listening is yes, this is the upcoming future, this is the future technology. But even after 10 years we couldn't touch the future, still we are telling it is a future technology. Yes, it has a lot of potential, but how much the this potential we can achieve, that is really a question. In fact, now many of the blockchain enthusiasts, many of them are thinking that okay, this is still becoming, even after 10, even a technology has came, and after 10 years also you are thinking it to be a future technology, then there might be something that probably is not addressed. So that is, there are a lot of there are a lot of people who has a lot of hope about this technology. There are a lot of people who has lost hope, and many people from the very beginning keep on saying that no, this is not something that is going to work. Okay, so these are news. So all these media news, we probably being a technologist, being person in the industry, we might not give that much importance of the media news, because media can make anything over, media can overhype on anything. But there are some certain promising factors about blockchain. Almost all these companies that we are seeing on the screen, they have made a huge investment and participation on blockchain. That means it, at least there are business who thinks there is a potential about this blockchain. Otherwise, this business will never would have invested money on that. And there is a huge investment on that. So we'll try to figure out how much a blockchain can go, what is the limitation of a blockchain, and how much it can deliver, and whatever we are listening in the market, that it is a disrupting technology, it can overpower everything, it blah blah blah, a lot of things we are hearing. But what exactly it can do, what is the use of a blockchain, that we will try to figure out. Don't think that blockchain is probably the solution of all the problem in the world. No, it is not like that. It is a technology. It has a potential use case, and it can solve some of the problem. Just hold on, please. Sorry. So this is the blockchain revenue industry that is coming up. So that is a projected one. Till 2019, it was up to the expectation, and I really do not know whether this is coming. And this is the different industries that is relying on blockchain. So obviously, finance sector is the most affected one, or finance sector is investing on blockchain in the most and it is really something that people are expecting might be get disrupted by this new technology. Now, the real problem that blockchain solves, it doesn't solve all the problem in the world, right? Some of the problem it is solved. So what is the exact problem definition that a blockchain solves? What is the problem? Can anybody tell me? Can you please tell me what is the problem, exact problem that a problem? And
Uh, Authenticity, chain of trust, integrity at a high level.
but that is already achieved by PKI. Why do we need a blockchain?
So blockchain actually is kind of a distributed ledger. So everybody is working simultaneously.
Yes. What is happening we know, but what is the problem? What is the problem definition? Why somebody all of a sudden thought of something, let us do something a distributed ledger and everybody will work on that both maja aayega. It's not like that. There must be a problem in the industry that
It's a
block
transparency. I believe it is transparency
transparency on what?
on any item you pick it up, let it from currency to
Is in
real
that
estate to
like all the data in the world, we can keep open all the transaction in the world. Will that bring more transparency in the all the bank transaction that all of us are doing? Will let us just make it open, make it transparent. Will that bring more transparency and will that replace blockchain someday?
yeah, you can track it from where the fund has come, where the fund has gone,
Okay.
right? And now if I talk about agriculture, we call it as from field to plate,
Mhm.
farm to plate, where uh, the where the food was harvested and how it traveled and how it came to my plate.
Mhm.
So I know from where I'm eating my food. So there
They
is
are
more transparency.
good. Yeah. So in the supply chain, blockchain is a very good use case, but the question is still the same. I could have tracked that using a simple SQL server, SQL database. I can track that using a simple Excel file also. Why do I need
Uh,
blockchain?
no, but there are multiple parties involved, right? So you can't track it
Multiple.
centrally. It
You
has,
just share the SQL, share an API with all the multiple parties. Everybody can just keep track and they can update the SQL database. Simple solution, right?
no, that is also the reason why it failed, right? It is not picking up because not everybody is digitized.
Yes, but blockchain is more digitized. If you want to implement blockchain, that is more of a digitalization requirement is there. But the problem that you said that everybody needs to update the thing. So okay, there is a central server and everybody can simply update in that central server. All you need to do is just create a web application, and everybody can access that either their mobile app or from their browser or wherever. They just need to enter the data and that will be tracked in the central server. That is actually a better approach for that. It's a very cheap solution and better and security wise also it is also much better. But why do we need
No, but yeah, but you're talking about only a single line of thread. A farm can sell it to 100 sellers,
Mhm.
right? And then they will have their own databases. So it's going to become more complex.
Okay, but will blockchain reduce that complexity?
Uh, Blockchain will, yeah, it will help in tracing back where the transactions are happening. So
Okay.
where the food was, for example, here,
So yes,
if I
we can trace, but my question is without blockchain also we have lot of simple and inexpensive solution to track that. For tracking that we really do not need to onboard blockchain. We have much big, efficient and inexpensive solution for tracking that one. That was my question. Okay. Let's see what exactly blockchain. Let's see what is the problem. Why blockchain is required for storing data. Blockchain is nothing but a technology to store data. That's all. But it solves a problem that normal data storage cannot solve. That's why blockchain is coming. So what are the classical data storage we use? Databases. We use file system, cloud. Okay. But the question is, are they tamper-proof or immutable? That means database for this database, there is somebody who is maintaining this database. Somebody is maintaining, somebody is owning, somebody is creating the database, and they can change anything in the database. We just trust them, they will not, but they can. Just imagine all our bank account balance. We just trust our bank that bank will not change that figure. If they increase, we don't mind, but if they will not decrease. That's what we just trust on the bank. But imagine that bank, that same SQL database or NoSQL database, whatever bank is using to track my transaction, to keep my ledger balance updated. Somebody can just create some false transaction and they can reduce my money. I cannot do anything. It is a trust that we are trusting the bank. We are trusting how the bank operates. We are trusting the people who are maintaining that database. Otherwise, our money is nothing but a integer in a SQL database, nothing else. That integer anybody can tamper. Similarly, if it is a file system, then also whatever I write on the file, somebody can tamper that. And in the cloud, yes, it is also possible. Cloud is nothing but like someone else's computer. Either it is Google, Elon Musk computer, or Sergey Brin's computer, or Jeff Bezos' computer. Someone else's computer. I am just using that computer to store my data. I am using that computer to doing some computation. That's all. That's what a cloud is. So I can use a S3 bucket. I can use anything else. I can use NoSQL database in AWS, whatever. But whatever I am using, none of these data store are tamper-proof. Especially, Praveen, what you wanted to tell here, especially when there are multiple parties involved, and all of those parties have access on the database, anybody can change any of those data.
Yeah. Yes.
That is the problem. Now, the problem is we have to create some database which is tamper-proof. One of the ways, now we know how to maintain integrity. We know a very good solution of that. That is called hash. We can create the hash every time for the database. Actually, that is happening. But that hash is also maintained by the same trusted authority who I trust. So they can change the database, then they can change the hash. There is no way we can find it. So that's the problem. So what it started with the oil industry. Exactly the similar situation that Praveen you were telling, started with the oil industry. And in oil industry, it is probably the billions and trillions dollar business where nobody trusts nobody, because it is a very big corporate is doing business with the governments, with different national government, with different nations. Who are you going to trust? In India, we can trust Indian government. In US, probably people will trust the White House. But when they are doing business with multiple nations and many of them are known enemies, how you can trust them that, hey, this is a database we are creating, and for your trillion or billion dollars of transaction, we are maintaining this database, and for when they are doing the business, they said, okay, this database is fine, and this database is maintained in Islamabad. Okay. Or maybe all these business transactions are happening with US, and they are saying that all the database and the file system and the cloud is located in China. Nobody trusts nobody. Neither the nation trusts another nation, nor they trust the corporations. The corporation doesn't trust the nations. So it's a totally untrusted situation. And the question is, who is going to maintain the database? One way is that let us create the copy all the database. Whenever there is a contract happens, will create a copy of database and it will be with everybody. Now the question is, what will happen if one of those databases is tampered? I just came and tampering my data and say, hey, my database says that this contract never happened. Then who is going to mediate that? We might say, okay, there are three parties and the majority wins. Come on, the other two parties might get a ally. They can tie up with themselves and they can just take out my money. They can do that. So the problem here is we need a technology by which it is immutable, inherently tamper-proof. Even if it is somebody wants to tamper the data, something will be broken. It will be found out. And we don't need any trusted authority for that because we don't trust anybody. That's where the blockchain comes. How it solves the problem? What is the technology behind that? Let us see that. Okay, and then remote control. Okay, you can see my screen. You guys can see my screen, right?
Yes, yes.
Yes.
Do you remember there is something called linked list?
Yes.
Do you remember linked list?
Yeah. Yes.
So linked list is nothing but the initial address of a structure or a block. Here we will have a lot of data written. And where is the next data? For that, from here it points. So there is a pointer that points where the next data you will get, right? So this pointer it will tell where after this data is exhausted, where the next data will start. So that pointer will be there. That is the address location. This is called the linked list, right? You remember that? Now let us do a very nice thing with this linked list. Let us take up one. Yes, there are datas. There are the next pointer location. So this is D1, this is D2, this is D3. And this is the address A2, 3, 4 something. This address and so on. And there is one more thing is left here, this box. What this box will contain? Any guess? Hash of 0, because this is the first block. Hash of B1. Not D1, I am just taking it as a block 1, B1, B2, B3, the entire block. So B1. This will contain hash of B3, B2, sorry. So this one will contain the hash of this entire block. This will come here. So this is the third block B3. B3 contains the hash of the previous block. B2 contains the hash of the previous block B1. So on. Now what is the beauty of this data structure?
Nobody can tamper either link also or data also.
Anything if you tamper here, the next link, if you just tamper anything in this D2, immediately if you go to the D3, it will find out that D2 is tampered. Like this hash will not match then. Even if a bit is changed, the hash value, half of the hash value will change. So if you tamper something here, the moment you reach B3, you can tell that, okay, something is tampered here. Right? So this is called a blockchain. Blockchain is nothing with money, nothing with supply chain, nothing else, nothing with your Litecoin, cryptocurrency or Bitcoin, nothing. This is blockchain. Simple, straight, and nice. So this has a definite problem to solve. It is creating an immutable data structure. The moment you change any of the data, when you go to the next block, it will be like you will find. Now there is only one way to tamper the data. Why? How? Now from B2, you change the address also. You just make an A address and also D2 change. And then address will start from here. Is D3 and it is actually will contain the tampered B2. Then again the link will go on. That is one way if somebody can attack. How we can solve that? Then the simple solution is make thousands of copy of the entire chain and distribute with all the people in the world. So that if somebody really wants to tamper it, they will have to change this address with all the people in the world, at least majority of them. Because if you share this data, such a way you will share this data that nobody will make out that what is written there, but just a block. Somebody has given me a data block. I really do not know what is there. I cannot read those data. But what I will do, I will keep that data with me. Whenever there is any problem happens, people will ask for my data. I will give that, and they will check, and they will check the data. That's all. So that's how that's why it is a distributed ledger. Create multiple copies of the same chain and distribute it with there are thousands of different people in the world. That's how. Okay. Now we know
I have
blockchain.
one question.
Sure.
Can you? So, how we can store the last block hashes? Because we are storing it in next one, right?
Usually the last block is null. So usually in any blockchain also, the last block is null.
Yeah, but hash of
Yes, last but one block cannot be like that cannot be. You can tamper last but one block. Always the last but one block, whatever is the last block. If you tamper, then it is very difficult to find out. But rest of the block will be fine. But only the last one are always under problematic situation. Now for that, what happens? That's why the blockchain. There are a lot of different mechanism of blockchain. How we can solve these kind of problem. One of the solution is consensus. So if you have ever tried to send a Bitcoin to somebody, if you have not tried, then you can try to send some Bitcoin to me. I won't mind. In that case, like when you send, it takes some time. It takes almost 30 minutes to 1 hour, or even sometimes two hours, more than 2 hours. Why? Because at least six of the Bitcoin miners, or six of those people who are keeping a track of these entire block, at least six of them will have to come in a consensus that, okay, this is a legitimate transaction. There is nothing problematic in the last block, and we are creating a new block out of this. Then it is fine. But until the new block is created, your transaction is never registered, or this transaction is never finalized. So even if you send the money, I will get the money after some time, until just like until the next block is created. That money will not be received in my wallet. Got your answer?
okay, okay.
Okay. So that is in terms of Bitcoin, but in any other blockchain also, the last block, whenever the until the next block is created, the last block is always a sensitive one. For that, we always need the consensus, and we always wait until the next block is created. We will not keep it open. So everybody will keep on this particular data. Every eyes will be on this. Rest of the thing are already intact. I don't care about rest of the data, but on this particular block, all the eyes, the stakeholders, all the stakeholders should keep an eye on this, because this is the most vulnerable point. And you are right. Okay. Now let us come to this. So all these databases are not by they are tamper proof, not by design, but just a trust. We just trust the bank, we trust the government, we trust the other organizations or the corporations, and that's why we just trust whatever they are maintaining. But here we are creating a separate type of data structure or the data storage that will give immutable data or tamper-proof data by design. This is what a blockchain is. So the technology behind blockchain is nothing more, nothing less. Okay, function we know. Okay, I already have since it is today's continuation of talk, that's why I have not explained the hash function. Remember, and I extend this linked list thing. This is the blockchain. Now, in real blockchain, this is a Bitcoin blockchain. There are different transactions, all these transaction TXTs, all these transactions, the previous hash is there. And there is something called norms. What is that? Okay. This is here comes the Bitcoin mining. So Kruta, I'm sorry, I couldn't pronounce your name. So
Yeah. Kruta is fine. Everybody calls me that.
Kruta Smita. Okay.
Krutadnyata.
Krutadmita. Okay. Krutadmita. Fine. Sorry for asking that. Okay. Krutadmita, what I was telling that. Okay. So in the blockchain, there are transactions, there are previous hash, and as Krutadmita said, the last block is always under a vulnerable condition. Now, what is the problem of creating a new block? Who can create a new block? Is anybody in the world can create a new block? I am doing a transaction, and this block is full. Now I need to check, go in the next block. Where this block will be located? And who can create that? For that, there are separate thousands of people, as it is shared. It is a distributed one. Many people are voluntarily or for money, they are doing the same thing. They are actually creating new block, and creating new block is a crazily crazily powerful process. It literally eats up your computation power. Just giving you okay. Just instead of going to my slide, I'm just explaining it in a separate way. Say for blockchain. Now we know what a blockchain is. Now let us think about a Bitcoin situation. Just any cryptocurrency. As we know, cryptocurrency is the biggest application of blockchain. So it can be used anywhere we need to use any immutable ledger. There we can use blockchain. No problem about that. But the biggest application is the cryptocurrency and the transaction of money. Now let us think about that situation. Just in terms of Bitcoin, what is happening in Bitcoin? What is a Bitcoin first of all? First of all, Bitcoin is nothing but creating a new block. Say there are thousands of people who has installed a particular software in their machine. Maybe I can run it on my machine. You can run it on your machine. Part can run a different server farm for that cluster computer. Everybody can run that particular software in their machine. It is just from the user's perspective, a very layman's language. From a user's perspective, all I need to do, I have to go to that blockchain website, that Bitcoin website. I have to download that exe file and install on my computer and keep it running for 24/7. That's all I need to do. That means I am part of the blockchain mining network. What happens? Anybody in the world is doing any transaction that is written in a block. Now that block is not finalized. Anybody can write, keep on writing anything, and whenever this transaction is happening, since there are 1,000 eyes, all those 1,000 eyes that keep on writing those data on a block. So there are thousands and thousands of such blocks are getting created, but the blocks are not finalized. Why? There is a challenge that you have to solve. If you can solve the challenge, then only you can say this block is finalized, this block is created. Only with the transaction it is fine, but that is not committing the block. You have to commit the block. How you can commit the block? Using hash. I think where is our hash? Now tell me, can you tell me one particular number text which will start with 10? Can anybody give me a one single text that will start with 0? Yeah. B space. This starts with 0. Any other number? Can you give any other number that starts with 0? Anybody else? Can you give? Is it possible to give any such number that will starts with a 0? That will start with a 0? Three space starts with a 0. So only way to do that is by brute forcing. I have to keep on trying different text, and some point of time I will see that it starts with 0. Now, what is the how about the challenge that I need 2 zeros in the beginning of the hash? If it starts with the 2 zeros, then then what happened? I'm telling, but I just need to create a hash for any number or any text so that initially there will be 2 zeros. How you can do that?
Brute forcing only.
Same brute. Less. I have not got yet. Still, keep on. I think this one 2 zeros. In fact, this gives 3 zeros also. Now, now just think about something. Say I have some data already. X transfers money to Y. E transfers money to it transfers money to P. Then said the next block address, next block is stored in this address. Okay, this is not a memory address, but the one like the ledger address in this ledger address. So these are the already data that is stored in a block. Now the challenge is you have to, there is a nonce, you have to write here something A, B, C. You have to keep on, if you have to brute force, keep on writing something so that in the beginning there will be not 1, not 2, but 30 zeros will be there. How you can do that? It is only by brute forcing. So this is the fixed data of the block. And now you have to find out a string here so that if you just add the string, the entire hash will start with 30 zeros.
That's where the processing power is.
That is the crazily that is why it takes a lot of computational power. Now you have to do, only way to do that is to brute force. And that's why SHA-256 is probably the most used algorithm in the world now at this point of time. It runs almost for 3 quintillions time per second just for mining this Bitcoin. So mining this Bitcoin is a very deceptive term. I would say creating a new block in Bitcoin, in the Bitcoin ledger. Now, what will happen if I can find these nonce, if I can find a particular string that will start with the 30, what will happen? I will be given some money. 10 years back, it used to be 7.5 Bitcoin. Now I think it is zero point 0.1 Bitcoin. So every few years, the reward will be half. That's how the entire algorithm is written. And every time I'm creating a new block, that means it is creating new Bitcoin, and that new generated Bitcoin is given to me. Whoever is creating this particular nonce. Now,
Okay. One
yes.
question. So this X transacts to Y whatever data. So I am creating nonce.
Okay. Here, right? Yeah, please tell me.
Yeah. So so that is data publicly available. How the data?
Yes. Block ledger.com. Blockchain.com also you will find. Where is the ledger? What is that? Etherbit is for Ethereum. Blockchain also. I think that is there. The link is here in my slide deck.
And how they have derived like number 30, like 30
Sorry?
zero.
Yeah, I am. Ledger watch. Blockchain.com should not be the one. Ledger sections. Yeah, Bitcoin.com. This is the one. Now these are the latest transaction that is happening. You can see. So that means the new block is created. This is the transaction. The block. These are the hash for each transaction. But how can I get the block? Bitcoin Explorer. Latest block, yes. This guy just created a new block. See, this is hex. 1, 2. Any block you just open, the hash will starts with this many of zeros.
How like why that 30 zero? Like 30 bits.
A number that algorithm says. That's all. Because I have to create a pattern, and only I have to do brute force to create the pattern. The pattern that came in the mind of Satoshi Nakamoto is okay. Let us start with 30 zeros. That's all. It's not, there is no hard and fast rule why 30 zeros. In fact, the other cryptocurrency uses some other patterns. Some says it will end with 7 ones, something like that. So it is with 30 zeros. Yes. Makes sense? What is a no? What a nonce is?
Yes.
Okay. Now we know what is a blockchain. Now we know what is the nonce, how to create a new blockchain, like how to create a new block. And some people says, if you create a new block, I will give you some reward. When it happens, how you are, I am going to give you reward? No, not dollar, not Indian rupees, not Bangladeshi rupees, nor anything else, not euro. I am creating a new kind of token. I am giving you that token. What I can do with the token, I don't know what you are going to do. But if you keep the token, somebody, if anybody else wants to accept that token, you can just do any transaction with him with the token. Fine, give me that token. I'm finding 30 zeros for your transaction. I found 30 zeros. They give me some token, and that token, if I go somewhere and somebody else is keen to use take that token and give me something in return, the transaction happens. Now, initial days, nobody wanted that. Only few websites for gaming websites they used to take bitcoins. But after some point of time, it's everybody wants to keep Bitcoin, or everybody wants to hold of Bitcoins. Everybody thinks that this is something that everybody else will need. But if tomorrow, if some point of time, all the people in the world thinks, hey, this Bitcoin is nothing, we are not going to use that, then no transaction will happen. Then the Bitcoin will be zero. The value of the Bitcoin. That's how the value of the Bitcoin comes, supply and demand. That's all. So how this token works? It's nothing different than gold. What is gold? Gold is a metal. First of all, it has few properties, very nice properties. When people first started the economy, they thought that okay, we need something to get rid of the barter system. Barter system doesn't work for us. We need some token. Using that token, we can do all the transactions. How that token would be like? For previously, they thought that okay, seashells we can use, but seashells has a problem. There is abundance of seashells, so that doesn't work. Then they thought, okay, we need something, some metallic thing which will stay there, which will not be broken. It is something that is completely useless. Like we can use wheat or rice as a currency, but the problem is we will eat them up. That's not a solution. So that's why we need a completely useless something. And metal is a durable one. So what is the completely useless metal in the world? That time people know, okay, gold is a completely useless metal in the world. Let us use this thing as a token. Whoever I'm giving a gold, that means it has some value. If anybody else in the world wants to accept the gold, he can give whatever service or commodities they want to give. They can simply do the transaction with gold. So it is completely useless. This is not consumable. These are the two properties. So that's why people started mining. Then we found gold. Then we found silver. Then we found diamond. All these things are completely useless things. First of all, this has to be useless. Then only we can call them precious. That's the irony of economy. And second thing is that they have it has a limited supply. It's not everybody can go and mine and find gold. It's not KGA. Okay. So there are some properties, and the gold perfectly holds that. That's why we took gold as a token. It is just a token by which we can do the transaction. That's how the economy started. Similarly, some smart people thought, okay, there are some natural elements which can be limited and which can be used as which can have some properties and which is also very useless. What is that? That is number. The number are also naturally abundant thing, but you can create some properties on the number. And if you say, okay, if this number holds this property, then that is something else, that's something called a token. Fine. So that's why they created number with 30 preceding zeros as a in their hash. So that is something is worth the money. So you create a hash with 30 defined zero hash on some particular pre defined data. You have to just create a nonce. You have to create 30 zeros and you will get the money. What is that money? It is a token, just like gold. Probably initially when people started transaction with gold, the same question was there, whether this is really going to stay, whether someday all the gold will be gold have value of zero, something like that. That time also people thought. Today also we are thinking, and it might happen. It might happen. It is gold is there for some thousands of years. But there are a lot of other currencies that came and went. There are a lot of other metal that came and went. Even one point of time in Europe, people wanted to do transaction with tulip flower. That used to happen. But similarly, we really do not know. We really cannot predict the future. But yes, economically, a number with a specific property is as good as gold when we take it as a token or the transaction unit of transaction. That's the thing. Now let us connect the dot. We need distributed secure by design data structure, which we got using blockchain, and blockchain is that. But blockchain was popular because of the money, because of new digital token was created, and nobody that knew that what to use, how to use that digital token. In fact, I believe now also nobody knows how to use this Bitcoin. I have a lot of Bitcoins. It has a lot of money because there is supply of demand in the market. But what this Bitcoin can buy, I really do not know. I can convert them into fiat currency. That is fine because there is demand. People are ready to pay money to get that Bitcoin. That's why I can do that. But if I just want to purchase a land using Bitcoin, there might be possible, might not be possible. I do not know. Okay. So it is Bitcoin is just one application, but blockchain is more than Bitcoin or cryptocurrency. It is an immutable ledger. It uses something called Markle chain. Markle chain is the same thing, that the same chain that I have shown, that the hash value, it will contain a hash of the previous block. That's called a Markle chain. And someone can create a bad block, but for that you have to justify it with 30 preceding zeros, and you have to create a new block. You have to mine a new Bitcoin. For that you need a lot of computational power. Not only you alone, there should be 6 different blocks that will justify that particular transaction, that will justify creation of that block. So 6 different person will need to come up with the same block. Then only we will say all the transaction in that block are valid. So that's how a new block is created, and every time somebody is creating a new block, is getting money. And the assumption here is, since it is a distributed one, people with most computational power will be with the mass. One person cannot get hold of all the computational power. That is the idea. But I really do not know how rational that idea is. Even now, this Web3 and all these things are coming. We are using blockchain and all. But I really do not know when only 10 or 15% in the world holds all the money of the world. They can purchase all the computational power in the world. That is quite possible. So I'm not very much comfortable with Web 3, 3.0 or blockchain, because one of the major assumption here is that since it is distributed, not one person can tamper. If one person want to tamper, they need at least half of the computational power of the entire blockchain network, which is assumed to be not possible, but in my belief, it is quite possible. If tomorrow Elon Musk wants something, wants all the computational power in the world, he can just simply buy that. He can simply buy all the computational power, and he can just create like the Dogecoin. He can just manipulate the entire Dogecoin blockchain. Nobody is going to stop that because he has that money. He has money more than money required to buy all the computers in the world. So it is possible. So I'm not comfortable with that. That is my personal view, but just try to understand the technology behind that, how it works. And someone can create bad blocks, but that will not be validated because every block needs to be validated by at least 6 persons in the blockchain network. very high computational power, we know. In fact, this is a very big concern. If lot of computational power is getting wasted for creating the bitcoins and doing the transaction, then what's the point of running this one? So it is also a threat for the environmental side as well. And this is a probabilistic consensus. Consensus means half of the network will think that if half of the network says if there is a bad block and if there is a tie that who is right and who is wrong, then if half of the network says somebody is right, then he is right. If some of the block is legitimate, then that block is legitimate. That's called a consensus. So blockchain, we can define blockchain is a digital ledger. Now we know what is a digital ledger. Records that are linked, secured, and shared across many computational networks. This is called a blockchain. We know what is distributed and it is immutable database. And this is how the blockchain database works. This is a DBMS work and blockchain database I just showed you. And this is how how you can create a block Bitcoin or how the Bitcoin database works. I just extend that one. Okay, Bitcoin main feature. Bitcoin is not blockchain. Use cases of blockchain. Okay. Now, can you please tell me where we can use the blockchain? Now, tell me. Now we know what a blockchain is. Now it cannot be used everywhere. In fact, I have seen many people tweeting about blockchain. Hey, let us completely get rid of our SQL database or MongoDB and let us use blockchain. In fact, many of the companies and startups boast that we are using blockchain to store our data. And my question is why? Why do you need blockchain to store the data? Why a SQL database was not working for you? What are the data that you are working with that requires that use case? So just without understanding, blindly moving to blockchain is really not a good idea because blockchain is crazily costly tool. It requires a lot of computational power. It is not a cheap tool. It requires a lot of computational power. Even if for sending a Bitcoin, you have to pay a lot of money for the people who are validating those transactions. The people in the network, they will eat up lot of money. So if you, I think for sending one Bitcoin, probably they are taking 0.03 or 0.04 Bitcoin for each transaction. So that is crazily costly thing. Now the question is, now the people who are boasting we are using blockchain to store our HR related data. We are using blockchain to store our something else. We are using blockchain to store my sales data. The question is why? What you are selling that you need a blockchain to create an immutable ledger? If you are selling oil, fine, I understand. If you are selling diamond or something very precious, I understand. If your sale volume is 1 billion per transaction, I can understand. Or even like 1 billion a day, I can understand. But you are selling something like a grocery, you are running a grocery shop and you are saying I am creating blockchain, or the hospitals they are saying I have created blockchain to store patient data. First of all, let us understand blockchain storing the data is good, but accessing a data will take a lot of time. It is not a SQL database that or a file system that I can just open the file and get the data. It is a linked list. Linked list means to get a data, you have to start from the beginning, then keep on searching and find it. So accessing data is always a costly affair. Maintaining the blockchain is a costly affair. So you should keep those data that really you want to be immutable, like timestamp data. That makes sense. Somebody cannot tamper anything with the timestamp. Like in that case, it makes sense. Like contracts, you can keep contracts, the transactions, those things should go in the blockchain. That's fine because nobody wants to tamper, but you want to keep your employee database and you are saying that I am using blockchain. In fact, I got this statements from somebody who says we are using blockchain to keep our employee data. Come on, why? For what is the problem that you even facing with SQL database. Why?
Yeah.
Why?
Because somebody sold them. That's why they are using.
We told them, exactly. That's the problem. So we are buying something without knowing what it does. So it is based for timestamp data, contract, transaction, or some data that is not relevant. So we are buying something without knowing what it does. So
Not audible.
So you're not audible.
hello, hello.
Yes, sir.
Can you
You
hear
are
me now?
not audible for.
Now you are audible.
Hello.
It's audible now, sir. We can hear you.
Can you hear me?
Yes, sir. We can.
Pranav, you were saying something, but I cannot hear you.
Uh, we are able to hear you, sir. It's audible.
Hello. Pranav, please keep on speaking.
Can you hear me now?
It's perfect. You guys can hear me also, right? Perfect. Okay. So blockchain has a typical use cases and one more data that we can store in blockchain, a video recording, like all the CCTV recording. But again, it is a very costly thing. Video, yes, that is a very good use case. I don't want my CCTV footage to be tamper proof, but the problem is it creates so much of data. Probably it will the data will overflow because creating a new block will take will take time. So even though it is a very good use case, but we cannot really use CCTV data stream for a blockchain. It will be too much of cost. Too much of cost. It's not possible. In fact, just imagine it is creating 1 GB of data, and it takes and the blockchain takes 1 hour to find out that 30 trillion visiting zeros. So so what will happen in the next 1 hours of data? It's crazily costly. So blockchain is not good for high performance transaction. It is not good for small organizations or networks. There is no point of doing that. It is not a database replacement. Many people says that blockchain is going to replace relational database. Blockchain will turn Oracle into their needs. Blockchain will replace file system. Every files will be on blockchain. No, it never can happen. At least the way blockchain works right now, it is crazily computationally overhead. That overhead that is crazily costly thing, and it's a huge overhead. It doesn't make sense. I sent some Bitcoin to from my one. I just tried to make a transaction from Bitcoin from my one wallet to another wallet. It took 2 hours and it took almost point 0.3 0.03 Bitcoin from that. I don't know why. I just forgot what is the recent charges, but it is very costly. So it is really not scalable. Even for somebody, if they want to use Bitcoin for their personal expenses, it's really not a scalable one. It's crazily costly. And some of the early application, if you guys have used this Brave browser, you know what I am telling. Brave browser actually works on a different blockchain, and that's why it rewards you. It gives you some token, and that token is called BTT, which is very similar to another cryptocurrency. It is just another cryptocurrency. BAT token, I guess. Yes. And how it works, like if you watch our advertisement, it will give you that BAT token. So that's very simple. And in the best part about Brave, what apart from our cryptography and blockchain stuff, best part about Brave, if you open any YouTube video, Brave browser simply cancels that video, cancels that advertisement. Like if you are watching YouTube on your laptop, then use Brave browser. There will be no advertisement. You will not see any advertisement unless you want some back token. In that case, you have to enable, and it will show you the advertisement. Once you see that, you will get some back token. You will get some cryptocurrency. Other, if you just disable that, you will not see any advertisement in YouTube. So that's a very beautiful thing that Brave has. And this is open source. That's why I'm not like, even though it is a browser, we should be very much careful about browsers. But it is open source, and I trust open source software more than any closed source one. Okay,
And
and
isn't it lost to YouTube? Means if all people are migrated to Brave.
that is lost to YouTube, but YouTube cannot do anything with that. Brave said, okay, this is, I'm just selling a browser, and that browser has an extension. That extension is open source. Now go and sue all the developer who has contributed in that open source project. And
Hmm.
YouTube really cannot
But
do much.
I can make changes in YouTube API, no? So if the
YouTube is
request is coming from Brave
trying that.
browser,
YouTube is trying to do that madly, but problem is there are smart people who are contributing in Brave browser as well.
But for Chrome
YouTube
also we have extension, right? Which can block the YouTube app.
Yes, there are a lot of extension, but extension also I do not like much because that might those extension browser extension might be vulnerable. So I usually do not use any extension that I really do not trust. And more, like only 2, 3 extensions that I use, and most of those extensions are either open source or from very trustable and reputed company. That's why I usually do not install any extension. But Brave browser is itself a browser which is good and which is open source, and it does that seamlessly. It even doesn't slow down your system, or it doesn't slow down your browser. It works seamlessly. So that's why I use Brave browser, and I use Brave browser only for watching YouTube or any. In fact, if you open any web page, it will not show any advertisement. That is a problem. But yeah, they have implemented it in that way. If you see any advertisement, you will get paid. That's a simple strategy they have. Okay. And the supply chain is a very
hmm.
good example for that. Music sells. How the copyright will be protected. For that also, blockchain people are using NFT. In case you have heard about NFT, NFT is something. So NFT, you can create something your own, some drawing, some picture, some song, and you can send it as you can create a NFT for that. That means whoever copies that song or whoever copies that picture, but the original owner will always be the same. And you can transfer that NFT to somebody. That means if you sell that digital asset to somebody, even though there are multiple copies in the world, but that particular, the original copy will be owned by someone. That's called NFT. It's very much similar to any painting. Like the painting of Mona Lisa, there are a lot of people who has copied the painting, but the original painting is only in the Louvre, right? So that's it. Somebody can sell that one, and so how you can track that? For that, there is a blockchain called NFT. Uh, I don't think we have time. Otherwise, the NFT I created some NFT and I was trying it trying here. So you can see DigitalOcean, I guess. So DigitalOcean is the one for NFT.
So how many bitcoins do you have?
That's the classified information. So I knew it from 2010. And that time it came very like I was one of the very early adapter of that, but I really did not know that what to do with the Bitcoin. That time we mined, me and my friend. In fact, we were that time in IIT Kharagpur, and what we did in our labs, there are some I think 100 or 200 computers. One night we run all the 200 computers together, and we just started mining the Bitcoin, because we really do not know what to do, how it works. And that time a Bitcoin cost around, in Indian money, it used to cost around 30 rupees. That's all. Half dollar, not even a half dollar. Like it's less than $1 that time. And that time in $2 is all something like that. And we just
You
run
could
all
have
the
sold
computers.
it now. But you could have sold it now. We have 30% tax.
I'm not finished the story. We
Okay.
got 2 point something Bitcoin we got. We are very happy. And then we found that with that Bitcoin, we can do nothing, just some online games we can play. And since me and my friend, we are not into that gaming thing and online game, we didn't play much. So we had that one. And then both of us had got our degree, came from Kharagpur and all those Bitcoin, the private key for that Bitcoin wallet was there in that computer that we used to use in our lab, because we just wanted to explore the thing. We really do not know what to do with the Bitcoin, and we never had any idea that Bitcoin will cost so much that today with that 2 point something Bitcoin, I can probably purchase a flat in Bangalore. I never had any idea about it. So we lost that 2 point something Bitcoin. In fact, when the Bitcoin value soared up, I again went to Kharagpur, went to the lab, then asked to the lab assistant, asked to my professor, took that took that machine that we used to use. And but the hard disk was formatted by then. The hard disk has been formatted for at least 10 times. So there's no hope that I can get that private key. Yeah, I lost some Bitcoin, and few Bitcoins later, I purchased few Bitcoin, not few Bitcoins, just point something Bitcoin. And yeah, for Ethereum, I have because Ethereum blockchain sounds more promising to me. Just don't take it as any investment advice, please. It is not like that. It is don't invest with these data points. I'm just sharing my own personal thought. For me, Ethereum blockchain is much more promising than that of Bitcoin blockchain. That's my personal opinion, and that's why I thought that Ethereum might run in a longer might stay in a longer run than Bitcoin. That's my personal opinion, but that is not a investment advice or anything. And I don't believe in investing in blockchain. It's not like that. I know that whatever money I have, in fact, whatever money means probably I have put only some $1,000 or so, and that too I have taken down. So even though whatever I have in the crypto, that is just like I started with $1,000 and then take out my $1,000 and whatever is there, I just that keep on growing, and I just purchase from one crypto to another crypto, something like that. I just keep on doing that just for my play and fun. I do not have any intention to make money out of that, because I do not know. If I would know, then probably by this time I would be a crore purti. But I know technology, unfortunately, but I do not have that vision. Make sense?
Yeah, got it. Private key is very important.
Private keys. Not to be the private. Okay, so we can stop here today. And
Yeah.
who wants to stay for another 15-20, let us try to understand what you guys are facing, facing problem with the assignment. Let us spend 10-15 minutes, and then maybe next day in the beginning we can beginning of the class we can start with that assignment. So what is the problem, Parth?
I was doing for a sonar cube, but I was not able to run.
Why?
Sonar hyphen scanner command not found. So some issue with path variable, I believe, but path is there in that this thing. Some configuration issue, I believe. So if you can show the initial configuration, then it will help.
Let me show that quickly.
But I used sonar cube. I don't know how many of them tried for sonar. Else we can take it up later one to one.
But let's see later. We can just quickly. It's already 5:30. Can you take another 10 minutes? That is the time you take for commute to your home. So that time also I am eating up.
Okay. Then we can see for sonar.
Do you know why I am using VMware this time? Why I am not using the WSL?
Sir, WSL gave me too much of trouble. I uninstalled.
No, WSL. No, that is not too much of trouble. You can just simply disable it from the Windows feature. But WSL, I always use WSL, but here I need to use a lot of Git command, and Git command will not work
Yeah,
in
not
that.
supporting. Yeah, it was not working actually.
Docker,
And
I'm going to run a Docker from here, so the Docker will not also work. That's why I need a separate VM. Okay, little bigger. Let's see, in my home, there is a, this is the location that I have shared with you guys.
Yeah, yeah, correct.
The sonar scanner that I have downloaded, right? And let's
Right.
open this one. You guys can see my screen.
Yes.
Okay, and I make it bigger. Reference. Custom font. Select. Now it is visible. There is no point, like there is no scope for you to miss. Okay, we have to run the sonar scanner, right? Docker. It's a command. It's a very big command, right? Sonar chip. Where is that? So slow. Okay, documentation. This is Docker. But you are with me, right? You understood what I'm doing.
Yeah, actually, I had downloaded the zip file
Okay.
and means on my localhost 9000, it is working. I can see the screen.
Okay. Paste. Extension and what is that? Sonar cube, right? Sonar cube. Oh, sorry. You should run here. You should run here. And I have downloaded the scanner from here. You also did the same thing, right? Analyzing the source code from here, you downloaded the scanners, right?
Yes, I downloaded the zip file actually.
Yes, I also downloaded the zip file and unzipped it.
Yeah, after unzipping, go to bin Linux, and we can just start the sh file.
Okay. Let me check.
Username, password is admin.
Still taking some time.
I don't know if I can run MS Team in two computers. Pranav, can I log in into MS Team from another computer?
Yeah, you can.
Okay.
I'll share the link. You have the link, no meeting link, so you can join
Yeah,
through that.
okay. Okay, it is showing you are already in this meeting on another device. So I'll add this device. Add this
Yeah,
device. Okay, I added this device. Let's see. Okay, I got logged in. Nice. So I can share my screen if
Okay, then
required.
I'm stopping my share.
Okay, then I'll share my screen. Yeah, is it visible? Oh,
Yes.
I can see in the next laptop as as well. So it is visible. So localhost is working. So in this folder,
I don't see anything. Anybody else who you guys can see?
we can see, sir.
I am able to see on my another laptop.
Yeah, even I'm able to see.
I'm the unfortunate fellow. Okay, let me see.
You're not able to see.
No.
Mm,
What about others? I'm able.
shall I share it again?
I can see.
Yeah, please do that. Probably I was sharing, that's why probably I got a problem.
Okay, I stopped share.
Sir, you can try one thing. You can like pin him, and then his screen will be visible when you
I
share.
shared. I shared
Oh,
again.
yeah, now I can see.
Okay. So I had downloaded the zip file.
Mm-hmm.
So I just started the Sonar, and I
Started.
can see. I can see I logged in admin account, so I can see the home page. I had created one project as well.
Now scroll down. No, it is locally. You are analyzing it locally.
I was analyzing locally.
Create a token.
So it was already generated. I need to generate it again then.
Yes, I think the token is lost. Yes. Now continue. Copy this one, but we don't need that because yeah. Now others. Select others.
Correct.
It is Linux machine. Just copy the entire thing.
Correct. So where to paste this entire thing?
Just
That
you have
is, I am
right
confused.
now where you
Hmm.
have git cloned, where you have done the git clone.
Hmm. This is the git clone.
Okay.
Yeah.
Now just okay. Just go to the parent folder. See,
This parent.
yeah, cd dot yes. Now paste it here, whatever you have copied.
Okay.
Okay, now just go to this source, dsonars dot source, right? Equals to dot. You need to change that one to Reva 2020.
Oh, shh.
You have to use the left arrow only.
I pressed up arrow.
But you have erased that yeah. No, just
I'll paste it again.
or use a notepad and just change it. Or left arrow, yeah, with the left arrow it will work.
Oh, it stopped. I have to go up arrow then.
Oh my god. Okay, do one thing.
I'll try in not.
No. Now just try up arrow. It will work. It is a trick. Just use the up arrow. Up arrow. Nothing. No. Enter. Just send enter. Now use the up arrow. Now this yes. Now you simply go to the dissonor and now it will work. You can use the control button, control and left, then it will just move. Yeah, fine. Now just write Reva 2020. Capital A. Just use the tab. Use the tab. Is it working?
Tab.
Okay, fine. Now just press enter. Oh, command not found. Okay.
Command
Sonar,
not found.
yes. Where have you downloaded the Sonar scanner?
In downloads.
Okay, you don't need to go. Just
Okay.
keep the path. Download, right? So tilde sign. Oh, just go there.
Home Kali downloads. Okay.
You can copy that path. You can copy that path.
Okay.
Sonar, this is Sonar Scanner you have downloaded, right? This is not the same Sonar Cube project that you have downloaded and compiled. Sonar Scanner is a different download file. It's a zip file.
Yeah. This is zip file.
Not that one, I guess. What is there? No. Just go to that Sonar Cube website. That's why you are not getting. You have not downloaded the Sonar. So these are two different two different things. One, the one you have downloaded as zip file is the for running these web application, right? The other one is for the scanner. That also you need to download. Just go to SonarCube official website.
Yeah, it got hanged actually. Machine got hanged. Something is working.
Yeah, open any browser, then we'll see the location for service and home system.
Okay.
I have sent the link. You can click on that. Yes, from here you need to download Linux 64-bit on the top. Don't go down.
Okay, this one.
Yes, this one you have to download.
But in Kali, I need to download, no?
Wherever you want to, anywhere you just download this thing.
So then I need
Yes.
to ship.
If you do not have any share folder, then you have to download it in Kali. Then close this window. No, this entire browser you just close. Is it working or the entire file is not working?
This is the usual every time. Okay, it recovered and goodness. Okay, so I need to download that
Yes,
and
you download that zip file, and then you will find that sonarscanner.sh in that zip file. So there is a bin folder. Inside the bin, you will find that.
yeah, this one only I downloaded. This is the same thing.
Is this the same thing? I don't think so. This is Sonar Scanner, and you downloaded Sonar Cube. These two are different.
Correct, correct. This is different. Yeah, this is different. So the same thing I need to do from this file.
Exactly. So the sonar scanner.sh, that command, it is not finding. So you have to give that sonar scanner.sh path. That file is located here in this zip file. Okay. Then it will seamlessly work.
Okay, I'll try.
Why don't you use
Else,
the Windows one?
In Windows also, it will show you the exact command you need to run, and there you have to download the zip file, and that time it is sonarscanner.exe or sonarscanner.bat. That's what you have to run.
yeah, I don't know why I did on Kali.
Yeah, that's why.
It's okay. And Linux is much more easy to do, right? All these things. In fact, I feel much more freedom when I work on Linux. Because there's a lot of
And
dependencies.
moreover, Kali, there's 2020 edition, which is will crash.
Kali is a problem. I use Ubuntu.
Yeah, Ubuntu.
In
Yeah,
fact, in
actually,
Ubuntu,
I saw Ubuntu, but it was 3 GB image size. So then I started on Kali.
okay, that's why
Hmm.
I had to save it.
I started, tried to save the time, but it backfired.
Wait for some time. Wait for some time till.
Yeah, it came. This one, so
Yes,
fast.
yes. It is a very small 41 MB.
Okay. So it is in downloads. So this one is downloads. Okay, everything got. So what was the file name? Sonar
Just
scanner.
up arrow.
Sonar scanner.
Yeah, Sonar scanner. Now CD. I think
B.
bin. See, now Sonar scanner is here. See.
Yes.
This is a file, I guess. It's not a direct. Now just run Sonar scan the use the app arrow up arrow. It works. No,
No.
you have to copy that thing once again. Or
So I need to start it again, no?
just here you can just any of these terminal you can find it using the up arrow.
No, I need to start that Sonar Cube again.
Yeah, that you need to start. But let's fire. Yeah, anyway you have to start. Then let's start that. We'll copy it again. Anyway, we have to start that one.
CD downloads. This is Sonar Cube. Okay. Okay. So it got started. Again, I need to take that token, no?
Yes.
It will take a while, couple of 5-10 seconds, I guess. Started. Got started. Okay. So now, where shall I run? Anywhere?
Yes. Anyway,
Anywhere. Let us do here.
That
okay.
is just downloaded, no, that's not installed. So I think you
Hmm.
need to run it where it was downloaded inside the bin folder.
Okay. No, you just go to in the beginning also you have to set so where the sonar scanner is located. It is in the download, right? So download
Yeah, it is in downloads, this one.
the
Yeah,
entire
there
path.
is a command.
Yeah, entire path you have to copy. Just
This one.
yeah, and paste it beginning in the beginning of that sonar scanner.sh. First paste it and then yeah, just use the home button on your keyboard.
Hmm.
Now paste it. Hmm. Which one?
Okay.
Oh, bin and then
Actually,
slash.
after bin, it took directly.
Bin and slash. Yeah. No. Now it will work. Surely it will work.
Yeah. So I had downloaded half of the things.
Now go to that portal. Wait for some time. Refresh this page.
It will refresh in
Or
few moments.
yeah, let's wait for some time.
Is my analysis done? If your analysis success, this page will be automatically refreshed in few moments.
Okay.
It over there command.
It's still happening actually. In the background we can see it's still going on.
Yeah,
It's not
Yeah.
over.
Hmm.
Now it's
No,
done.
no. Yeah, it's done. Yeah.
Now you can see
Okay.
all the
So I changed so many variables and I did lot of research rather than downloading sonar scanner.
in the first day. Actually, I told there are two different exe files. One is agent. This one, the Sonar scanner is the agent, and the other one is the server. So you downloaded the server, and this is the agent. And see, there are
Uh,
45
yeah.
vulnerability 0, There are 42 security hotspots. All these things are there. So now you can click on that. Click on anything, any of the bugs. Now click on any of that. It'll take you directly to the code where it is. No, not there. In general on that box here. Just click on that. It will take you exactly in the code location of where the problem might be. Okay.
Got it.
So where is the code loaded?
Sorry.
The code, where do we
Code
use
is
the code?
code is Git repo. So
Any GitLab from GitLab, you can download anything, or I have created one that I shared.
this one, Reva. This is the repo.
I'm sharing the location once again.
Okay, did you give this location in command?
Or the date.
No, actually we created here, no? While doing this thing, we mentioned that path.
So git clone is the command that you have to run. Can I please open the link that I have just shared? I just shared.
If I go to return to list or a home page, something is a projects. Okay.
No, you have to come to Windows first.
So this is Reva. Okay, now I have already created, so it is not showing.
Yes.
Okay, I can create a new project and I can show.
Exactly.
So here you can mention Reva 2 setup. So here you will select local. Reva 3, generate, continue, other, Linux. This one. And here we'll mention.
Oh, the
Reva.
sources you need to mention where that.
Yes, source will mention Reva. Okay, I'll do up arrow. Reva. Sorry, source is Reva 2022.
Okay, and in that Reva 22, sir, as you provided some link, we can download the.
But if it is not there in the okay, this was in home, so it picked up. Else we need to give the full path.
Exactly.
Else you need to give the full path.
Okay, I'm just stopping the share. Okay.
Okay, so let's call off the day.
Yeah, thank you.
Regarding that code, we have to write, right, for the cipher.
Yes.
There was one lesson, right?
Yes,
So, any leads for that, links for that to refer, sir. I'm not a coder, so basically.
Okay, in that case, you can just create a flowchart, no problem.
Okay.
Okay. Okay. Thank you. Thank you, everybody.
So 18th
Okay.
is your deadline, right? For the first 3 assignments.
Sorry?
18th next week. That's the deadline, right?
Yes, 18th.
All three on 18th?
Yeah, you can
Make
submit
sometime.
by 18th anytime.
Second assignment was watching a movie, no?
Yeah, second is watching movie.
And just write some review. That might be one-liner, two-liner. Just write a review.
Okay.
You can send that review to me as a mail, or you can write it in the IMDb and you can send me the link. IMDb
Yeah, should be fine. We can write a review. So fourth assignment we'll give after next week.
Yes.
Fourth assignment.
Fourth
It is
assignment.
not uploaded. Yeah, it is not uploaded.
It's not. It's the deadline is 24th, right?
Yes. Sorry, Vijay, we are. I can't hear you.
Your voice is breaking.
Okay. Any better? I was sitting. The recording is done until now.
Okay. Please tell me.
Sorry, what?
Will you please type it? I think that would be better.
Yeah, we're not able to hear. I heard recording something.
That's a good question. Pranam might answer.
Okay, for Sonar Cube, people would be
I think it is
curious.
recorded. It's still getting recorded, right?
Yeah,
Yeah.
it is recorded, no? Sonar Cube. Yeah, then should be fine.
Okay. Okay. Thank you, guys. Bye.
Okay, bye bye.
Thank you, sir.